So up under week 1, you should find chapter 1 slides. Okay, come on, you can do it. Come on, modules. Oh, there it is. You should find chapter 1 slides. That's what I'm going to go through. Okay. I did check today, and the book and slides are very similar. The book is much more detailed. So if I don't cover it in depth enough on the slides, please refer to the book or just ask me. Okay. I've been using Python for many years, and if I don't know the answer, I can figure it out pretty darn quickly. Okay. So let's cover a few of these slides. Chapter 1 is always a boring thing. Okay. It's an introduction. You should know most of this chapter already, but we're going to go through it. Okay. We're going to learn about computer, software, programming, how to write code, how to diagnose errors, how pseudocode works, and all that stuff in this chapter. Okay. Algorithm. Let's talk about algorithms. Okay. So you guys came to class today, which is a good thing. How did you know to come to class today? You looked at your schedule, and you probably got an email from me. So you had something you could check. Oh, is it Monday? Is it 12:30? So you kind of had a plan to figure out if you had to come to class. That would be an algorithm. They set, like it says here, is a step-by-step description of how to solve a problem. Okay, yesterday, yesterday my stepdaughter came to us and said, oh, I need some special paper for school. So the problem we had was we need some special paper for school. So that's our problem. How can I solve that problem? What do you think? Go to Walmart, buy paper. So the algorithm to solve the problem of not enough paper, or not the correct paper, because you need the special paper, was get in a car, drive to Walmart, search stinking Walmart so you can find the right paper, purchase it, and go home. So really, algorithms are ways to solve problems. Now, those are very easy problems to solve, but there's a lot tougher ones out there. Like I've been reading a bunch of books about Elon Musk. Y'all know Elon Musk? SpaceX? You kind of need to know what you're doing. And the cool thing with Python, you can compile it. You try to run it up. That didn't work. Change it up. Can you imagine making a rocket up? That didn't work. Up that. You would hopefully they did it right the first time. Actually, he didn't. That's okay. He's there now. So an algorithm is really just a step-by-step description of how to solve a problem, whatever the problem is. Okay. Computer program tells the computer the sequence of steps needed to complete a task. We are actually going to write computer programs in this class. Very basic ones to start with. It says the program consists of a very large number of primitive, simple instructions. They don't have to have a large number, but they could be a large number. Computers can carry out a wide range of tasks, from everything from calculators to VR to what's some of the coolest thing we've seen lately? Anybody? It's got to be something cool you've seen. Walking robots. Walking robots, there you go. See the robots that can flip? It's like crazy stuff. It's crazy. Okay. And program is the art of designing, implementing, and testing a computer program. Okay. Do you think it's possible to write a program without errors? I would say no. Hello World we're going to write today or Wednesday. Hello World is a very basic program. It's normally one line. Could you write that without an error, you think? To guarantee it's going to work on every single computer?
Not very much. It's a program that doesn't work on that, not on every computer.
See, that's the problem. We can write Hello World that work fine here. And it will most likely work on Summer's MacBook. But will it work on every other computer out there? I used to do beta testing. Y'all know what beta testing is? We try stuff out. Well, before Windows Defragmenter was out, Executive Software wrote software called Diskkeeper. And I was one of their beta testers. They would make the new version. They would send it to me. I would install it, play with it, and tell if there's errors. It was funny because I got an error one day. And it's like, volume corrupt, restore from backup. Is that a good thing or bad thing? That's a very bad thing. Basically saying my C drive is corrupt. What, to restore it. So I contacted them and they were freaking out. Literally I contacted one evening, sent them the error I found. They literally FedEx overnighted a box of cookies and some other crap to my house. I don't know why, probably just to make me happy or something. But they couldn't figure out what the heck the error was. They kept working on it over and over and over, and I kept getting to I could repeat the error. Well, it turns out their software, when run with a specific version of McAfee antivirus, causes a false error. It was bizarre. Here's how they fixed it. You know that README file you get when you buy software? It's like on line 82. When running with McAfee, blah, 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 ignore the error. That's not a fix, but that's what they did. So it was, you know, so programming, they say the act of it, I would kind of say the art of it. Because I've seen some people that can, I mean, Jairus downstairs, he can write some code. That dude is sharp. I need him to get his darn bachelor's degree so he can start teaching here. He loves to program. I love programming as well, but my problem is I got too many other darn classes to teach. I can't do just the programming classes. Because I actually have a degree in computer science, which is, you know, I've had Fortran and COBOL and Pascal and C and C++ and C# and Java. I had all those classes. I don't get to teach them. So programming is awesome. And you can solve problems with it. Make your life easier. We're in 131, there's actually a board of projects they're working on. I added one to the project. You know those mini blinds back there in the back? Well, there's a program out there called Smart Blinds, which you can buy, which will tilt your blinds for you and go up and down for you. We're going to make that on a Raspberry Pi, all written in Python. We're going to make it. So that's one of the projects we're going to work on this semester. That can't be hard. I mean, all you got to do is there's a little, you know, where the strings go, there's a thing in there. You can just rotate it. Raspberry Pis can very easily rotate motors. Because that swipe card on 131, if you haven't seen it, you need to go check it out. That's all run by Raspberry Pi. My door, if you look at 104, my door has that schedule that keeps changing on it. That's all written into a Raspberry Pi as well. We launched 2 helium balloons so far. One 2 years ago, which worked perfectly. And this last year, crashed and burned terribly. But that was all written on Raspberry Pis as well. So a lot of cool stuff to play with. So if you're interested in it, you know, get involved. Okay, let's talk about hardware and software. Hardware is this stuff we can touch, the physical computer system. Okay, so would this phone be considered hardware? Yeah, it is. I can touch it. And hardware runs software. Hardware could be the monitor, the mouse, the external storage. But that stuff is changing so much. I mean, cameras, projectors, everything is changing. The CPU, or the central processing unit, is pretty much the brains of the computer. Okay? It controls the data processing. Then we have storage. We have hard drives, flash drives, CD-ROM drives. I actually wrote something to a CD-ROM the other day. Probably the first time in 5 years. When's the last time you wrote something to a CD-ROM or DVD? So I get to speak tomorrow at Tesla on Tinker, which is their software engineering division. I'm a guest speaker for them tomorrow. You cannot bring any flash drives into Tinker. My files are too big to email it to them. So how do you get it there? They can't access Google Drive or Dropbox, so how do I get them the file? So I had to put it on a darn DVD. I was like, how do you do that? But I did it. I put it on there and hopefully got it. And Thursday, see, I was in the paper, not yesterday, but last Sunday I was in the paper. And it was talking about, you know, breaking the iPhones. But I guess the Oklahoma Trucking Association saw it. So they called me the next morning. I got to go to Tulsa to speak at their convention Thursday. So if you're looking for me Tuesday afternoon or Thursday, I won't be here. So I'm going to go speak at different places. But I mean, the way we store stuff on hard drive. Anyone got an SSD at home? I got a solid state drive. Wow. I have a Microsoft Surface. That thing boots up in 10 seconds. Literally, totally up and ready to use it in 10 seconds. I mean, come on, how long did you guys even wait for yours to log in here? It's crazy. But we have hard drives, we store stuff on them. So Google Drive has unlimited storage for life. How is that even possible? Does anyone use Google Photos? The rest of you don't. 2 of you use Google. Okay, you need to use Google Photos. First of all, they store your photos forever for free. Okay? And the cool thing is, see, when we write something, I don't have a flash drive with me, but say I wrote something and stored it on a flash drive. How long is it going to last?
Until it gets corrupted.
until it gets corrupted. But will the magnetism sooner or later go away? It will. Same with the CD-ROM, DVD. The magnetism on those devices will fail positively. They have something called an MTF, mean time to failure. This phone will crash. Everything will die. But what Google Photo does, and actually Google Drive does as well, Google has servers all over the world. Obviously, high priority paying clients get quicker access. But at all times, data is literally cruising all over the world on Google servers. Because they have to make room for stuff. They have to transfer stuff back and forth. So what's happening is your photos and your Google Drive files are literally moving around Google at all times. And since they're moving around, what they actually do is they take your file, they copy it to its destination, verify it made it correctly, and then delete the old one. So it's perfect. I mean, what's the odds of every Google server crash at the same time? It's not going to happen. There's a book out there called The Plex, or In the Plex by Stephen Levy. It's all about Google. But it's really amazing that what they're doing, they're literally moving data around so much. And they, believe it or not, Google buys the absolute cheapest machines you can possibly buy. You ever heard of an e-machine before? E-machines were sold at Best Buy for a while. They were the only machine that literally, if you had any problem whatsoever, you brought it to Best Buy and they threw it away and gave you a new one. Because they were that cheap. Google buys machines cheaper than that. Their system is written, they know they will have so many failures. Their redundancy is so amazing. They don't care. They just, whatever that crashed, throw a new one in there. Their data warehouse is literally just people swapping out hard drives all day long. But it's written, I mean, it's amazing. Look, read that book In the Plex. It's amazing. I would have never thought that. But since they're moving our stuff around, you know, he has a flash drive back there. So that flash drive, you know, he might leave it in his car. It might get hot. It might get stepped on. It might get lost. But Google ain't going to happen. It's going to be there forever. And, you know, I did something the other day. I have many backup services. I have lost data before. Well, July 3rd of this year, I was copying my stuff off my personal Google Drive, which was running out of space because we're limited, to my Rose State one, which is unlimited space. So I was very meticulous. I copied everything over. I verified 100% it was there. So then I went to my personal one and deleted the files. Verified they were there. They were still there. Then I dumped the trash from there. And then all my stuff died. What had happened was, if you use Google Sheets or Google Docs, you know what I'm talking about? What you see is actually a link to an object on the Google network. So when I copied it from my personal account to my Rose State account, I copied the link. The object never moved. Then when I finally deleted it from my personal account, it deleted the object and the link. So that all the links from on my Rose State from my personal stuff went nowhere. I lost, I mean, not that big, it was maybe 100 files. Because PDFs and all that stuff was fine. I didn't lose any Word documents, PDFs. It was just the Google Drive, you know, Google Sheets, Google Docs, Google Sheets, those kinds of stuff, because of the way they store it. So what do you do at that point? Because remember, I dumped the trash. I literally did everything. I deleted it off my computer at home because I was running out of space there. What do you do? Google can restore any file for 25 days. I could not believe it. Sure enough. So I went online with Google, and they're like, well, when did you delete it? And it was literally the day before. And I said, yeah, I did it. My bad. And they're like, okay, you can get it back. Not a problem. They said, there's a problem. We're going to restore everything. So, and I had a bunch of subfolders, which while it literally took over a day to restore. There was that much stuff. And when it came in, when it started to restore, I'm like, oh, well, I don't need that. I deleted it again. Well, I deleted the folder structure. So it literally put all my files in the root directory. And I literally had to click, 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 delete, click thousands of times. But I got my files back, which was a good thing. I've learned a valuable lesson. Hopefully you don't have that problem. Because when you copy on Google, at least Sheets and Docs, you're really copying a link, not actually moving the object itself. Because I didn't even think about it. But if you look at a Google Sheet now, I don't care how much data is in, it's going to be about 2K. Because that's just the link to the actual document. Scary stuff. Okay. Flash drive. I have a 2 terabyte flash drive at home. I think I paid $19 for it. I'm scared to use it. Can you see why? I paid like basically nothing for it. And I'm worried that it's not going to work. It was one of those things, oh, buy this, and I bought it. Still have not used it. Maybe I'll bring it and let someone try it. I'm just worried if I put something on it, it doesn't work. CD-ROM drives, again, I had to use one just the other day. Okay. Input-output devices, Star Trek 4, Voyage Home. Seen that movie? That movie's amazing. They go back in time, and Scotty's there, and he's like, computer. Remember he was talking to the mouse? That's a good part. Yeah, it's a good part of the movie. If you haven't seen it, you need to go watch the movie. But our input devices are changing. Okay? Closed captioning. Did you know YouTube, like if you watch any of my videos on YouTube, you can just click the closed caption. I no longer have to do the closed. It does it automatically now. It's not great. Because unless I sit there and enunciate really well, you're going to get some weird stuff in there. But it's really decent. Now, I had one handicapped student who needed closed captioning, and he said, oh, yeah, because that's totally fine. I can totally understand what you're saying. I'm like, sweet. So, okay. But input devices are changing so frequently. Now, I got a all-in-one printer at home. I don't believe in all-in-one printers, but I bought one years ago, and it still works, which is good. But I want to get a new one. But my problem is, when do I buy the new one? Do I buy it today? Because tomorrow there's going to be something better. It's like I also need to get a new refrigerator. When do you buy the refrigerator? Because next week there'll be a new refrigerator, and we got that another one. And sooner or later, it's like, when do you buy the refrigerator?
It depends on if you're wanting to get a deal or if you want to get the best offer.
Yeah, see, I used to try to get the deal, but I drove a guy's Lexus one time that ruined me for life. Because I used to buy the base model car and truck. I drove his Lexus. And then when I went to buy my base model truck, it wasn't in stock. So they loaned me the one with all the options. Literally driving home, I call it, dude, no. I'm keeping this one. Because it's like, wow. So that's what I do. I buy the better ones. But yeah, I don't know. So input's changing. I mean, Ed Wolf downstairs, he teaches business communications. He's got the LG refrigerator where you tap it twice and it turns the light on so you can see what's inside your refrigerator without opening the door. Anyone got that one?
That's crazy.
Like a camera inside?
Yeah. So it's like, wow. I don't know. I think they sell it. Yeah. My problem is, okay, my mother-in-law now lives with me. Not a good thing. But she brought her washing machine. Thank God, because my washing machine, which is like 25-year-old Maytag, finally died. But that Samsung washing machine, the back panel, the metal is like aluminum foil. It's literally, I can take it and just bend it. It's like there's nothing to it. So you push on it, it literally makes a dent in it with your finger. Still working. But, so my deal is, if you're buying Samsung, what do you buy that's Samsung? Maybe the virus phone, the Android phone. But do you buy a refrigerator or a washing machine? I just have an issue buying a Samsung washing machine.
Samsung like, washing machines were blowing up too, just like the.
Yeah, go on Home Depot. They're always advertising their Samsung refrigerators and washing machine. Man, read the reviews. Oh my God. You'll never buy one. By reading those reviews, it's like, holy moly. All right, continue on. Okay, here we got a picture of a mouse, trackball, printer, keyboard. We all know what that is. They connect via ports, which are connected to a bus, which interface with our CPU and our memory, and also our controllers and our network, and that gives us output to all kinds of different things. I got some new speakers recently. I got Sonos. You ever heard of Sonos? Well, I bought 3 different kinds and finally got the one I want. I've literally returned so many that Best Buy has banned me from returning anything for the next 18 months.
Really?
I got that notice
Wow.
because the guy told me this would work, and it didn't. So I returned. So then they said, oh, in August, they're coming out with the one that does work. So I went back in August. Yes, this now works. It didn't work again. So I had to buy the third set. I literally got it's the whatever, the compute, whatever it is. They banned me from returning anything at Best Buy. So I contacted corporate because I'm a very boisterous person. I said, here's the deal. I'm fine with not returning anything to Best Buy again. What that means is I will not be buying anything at Best Buy. Because if I need to return something that's defective, I'm going to return it. So I said, if you don't want me to return anything for 18 months, don't expect me to buy anything for 18 months. So the guy's like, we have removed that from your account. I says, it's not, so what they have people doing is they'll buy something, then return it. Now it's an open box. They got to discount it by 10 or 20%. Then they'll go, Best Buy has a policy that if you return something at their store, they cannot put it back on the shelves in that store. They put it on the shelves in a different store. That way you can't just go back in the next day and buy it or tell your friend, hey, I'm returning a speaker, and they buy it at 20% off. But I mean, I had a legitimate reason. I wasn't trying to scam the system. But yeah. So I love my speakers. Was it yesterday? Yeah, it was Sunday. We got out of bed. We wanted to wake everybody up. I got one in the kitchen, one in the living room, one in my bedroom. I took one of my playlists. Y'all heard the Gummy Bear song?
Oh my God.
Yeah. I put the Gummy Bear song on all the speakers in the house, really loud. Everybody was awake. It was awesome. But, I mean, the output capabilities now are amazing. I mean, input, output, everything's changing so much. Okay. CPU has what's called the control unit and the arithmetic logic unit. Okay. Control things and do math, basically. Okay. It says all resources are managed by the control unit, handles communications, it handles I/O, with input and output. It reads and interprets instructions, okay, and usually provides timing. So the control unit does a lot of stuff for us. The arithmetic logic unit pretty much does math. Okay. Now, do you all know what language a computer works with? Does it understand English?
Binary.
It's really binary. It's really binary. But when we write stuff, it's actually compiled down to assembly language, which is very close. And then, that's a whole nother class. But really, the math of the computer, we'll talk about math later on. But what do you think is, I'll cover later. But binary makes math so easy. Okay, you can do so much more with it. We'll leave it at that for now. Okay. Now, storage, we have primary storage and secondary storage. Okay, primary, memory chips, circuit cards, stuff that's on all the time. They have it as long as there's power. You turn your computer on, something's running in memory. When you lose power, that's gone. Okay. Secondary storage is like our hard drive, our CD-ROM drive, our flash drive, stuff like that. Okay. These things are changing all the time as well. Okay. There's a new type of memory out. Can't think of the name of it. It's just amazing what they're starting to do with this stuff. The speed, the size, everything is going crazy nowadays. Okay. It says computers store both data and programs. Okay. When I first started playing with computers many years ago, I learned on a TRS-80 color computer. Let's see if I can find a picture of that computer. Let's try it. TRS-80 color computer. Oh, there it is. This right here, this guy, that's what I learned on. Guess what kind of storage it had? None. No storage. Mine had none. So I would turn it on. I still remember there was this horse racing game. So I would sit there and write the entire program, run it, play the game, turn it off. Next day, write the entire program again. But I think that's why I like programming, because I got used to programming. But that's what I learned on. I mean, think of that. Mine did not have the little slot where you could put in the storage on. Mine didn't have that. But it was darn close. And it's just amazing what's out there, what we have nowadays. Okay. So, secondary storage, again, stuff that is persistent, even if we lose power. It says computers Why is it humming? That's speaker here or something? Oh, there we go. Driving me crazy. Sorry. Okay, so computers store both data and programs. Programs are great, but programs without data are pretty boring. Remember when websites used to be static? You know, as you go to a website and it showed you something. Nowadays, aren't they all dynamic? Like FedEx. First time you go to FedEx, it asks you where you're from. And then it always shows you in English. Anyone ever go to like Mexico and bring up Google? Guess what language is in? Spanish. I use, anyone ever heard of Tor? Tor browser? Y'all should use Tor, it's awesome. I love Tor because sometimes you connect to a node in Italy and you bring up Google and it's in Italian. Or, you know, so it's pretty funny. It kind of messes with things because obviously your location services are off. I don't use the Tor browser to check on a UPS package because it's going to come up in a different, like Chinese or something sometimes, depending on where the node you connect in is. But, so yeah, we have programs and we have data. Okay, memory. So the simple way to envision memory is a table of cells. Think of like a spreadsheet. It's either on or off. It says a typical computer has between 4 gigs and 32 gigs of RAM. How much y'all got? Anyone got a lot of memory?
Got 16.
16 is awesome. Anyone got above 16? What do you got in yours?
Got 32.
Nice, 32. These probably only have about 4 gigs in there in this classroom. But, okay. Running Windows 7, I think we're running Windows 7 on these, aren't we?
Yeah.
What good is over 4 gigs of RAM? Anybody? Not. Worthless. They can't do a darn thing with it. But if you're running Windows 10 and other OSs, you can take advantage of all this stuff. You don't normally need that much memory, but it makes things run so much better, especially when you're running virtual machines and stuff like that. It's really nice to have more memory. Because what happens is, think of how many phone numbers you can remember. Nowadays, what do we remember? None. Can't even remember our own phone numbers because it's all on our phones. But what if you could remember every phone number you ever heard? That's kind of like the more memory. The more memory you got, the more stuff you can remember. And if the computer can remember it, it can function faster. It no longer has to go out to the secondary storage, which is, you know, massively slower compared to internal memory. So it no longer has to go out to the hard drive and say, hey, what's Bob's phone number? Because it already knows it. And especially when you're running multiple programs or browsers with multiple windows, like in Chrome, every tab in Chrome is brought up as a separate instance of Chrome. So if one crashes, it theoretically shouldn't crash the others. But the more memory you have, the more things you can run in there. And when you run out, then it has to start paging it. It writes it out to a page file or somewhere else, some other storage medium, just to load in something else. So, yeah. Okay. It says, how big is a gigabyte? So a byte is 8 bits. A bit is 1 or 0. Okay. So on or off, 1 or 0. Okay. A byte is 8 bits. A kilobyte is 1,000 bytes, which is really 1024. Okay. Then a megabyte is a lot more. Then a gigabyte is a lot more than that. Okay. One of my first really good computers I bought, I forget the exact model it was, but I bought a 20 megabyte hard drive. It cost me hundreds of dollars. I remember upgrading my computer from 1 megabyte of memory to 2. From 1 meg to 2 cost me $600. I mean, that's only for 1 meg. I mean, you have gigs now. Imagine only have 1 meg. When I originally bought my computer, I only had 640K in memory. I had to add the individual chips to get it up to 1 meg. And then I had to add the add-on card to get it up to 2 megs. That computer cost me $3,000.
The files are relatively smaller, though.
Right, they were much smaller. Our OSs didn't take up gigabytes. I mean, Windows 95 used to ship on 14 floppy disks. Okay, Windows 3.1 was like on 10 floppy disks. So, you know, they were a lot smaller. Obviously, graphics weren't there. But still, I mean, yeah. Okay, let's continue on. Executing a program. How's that clock? It's actually on time for once. Okay. So program instructions data such as text, numbers, and videos are stored in digital format. Okay. When a program is started, it's brought into memory. The CPU can run it. Everything has to be brought into the CPU or into memory so that the CPU can process it. nothing runs. So even if you have a flash drive, you know, if you're going to double click on that PowerPoint presentation, it still has to load it into memory before it can do something with it. You can't really run it off the flash drive. Okay? And the CPU, it says, runs one instruction at a time. So what if you have multi-core, multi-threaded? They can do more than one thing at a time, but technically they're just changing back and forth really fast. You really don't notice it. Okay. All right, it says the instructions and user input guide the flow of execution. That's where, you know, we provide inputs, we log in. Like our computer sits there at the login prompt until we log in. And then it does more, then it loads more stuff. Okay. So we have this whole Control-Alt-Delete thing we do to log in. Does anyone know why? Why'd they come up with that? Well, the guy, I was reading a book, let's see, the guy, Eisenstadt, I can't remember his name now. He developed that. He came up with it and asked him why. He goes, that's the worst mistake I've ever made in my life. He just tried to come up with something that didn't mean anything else, but he's like, yeah, it was stupid. But we're stuck with it. You know, it's one of those things. You know, it's like Android, we're stuck with it, but why get one? Has anyone got an Android phone in here? I feel sorry for them.
Sorry.
Okay. Software. So is typically realized as an application program. We have Office, we have Word, we have Chrome, we have Edge, we have Android. Okay. Microsoft Word is an example. Computer games are examples. Operating systems is also software. Okay. So the sequence of instructions and decisions implemented in some language that transfer to a format that can be executed. Okay. Every program starts off with the first line of code, and it keeps building more and more and more. I wrote a compiler program when I was at the University of Tulsa. I think it was a little over 5,000 lines of code when I was done. Still wasn't perfect. I wrote a network sniffer that was probably a good 2,500 or 3,000 lines of code. And the funny thing was, it didn't work correctly. But there was one part of my program I could not get to work for nothing. So a friend of mine was in the same class, and he got his to work. Because, you know, he shared we had to write a report on our software because it's very complex. We had to write a report of everything it does because there's no way the instructor would test everything. And he got his to work. So I tried and tried and tried. Right near the end of the semester, I'm like, John, how did you possibly get this to work? Because it says it in his report that it worked. Because it says it in my report, doesn't it? Yeah, he goes, he's not going to test that. Because mine don't work either. I'm like, oh, you sly dog. So I put it in there that it worked, and they never tested that part. So I got 100. But I will test yours. 100%. But software is really instructions. Okay. It says computers execute very basic instructions in rapid succession. When you write software, your CPU doesn't understand Java. It doesn't understand Python. It really understands assembly language instructions. So everything is compiled down to that. We actually have a reverse engineering class, which we take programs that are compiled and work on them backwards. We actually learn how to remove passwords and other stuff from programs and stuff like that. Okay. So the program is the act of designing and implementing computer programs. Okay, and they're a lot of fun. Okay, almost out of time. So I'm going to stop there at software. We're going to pick up at algorithms next time, which is slide 13. Okay. Yes.